So now we're turning to difference in difference estimates. And this is really a workhorse of a lot of policy research, but it's also something that practitioners may be able to implement in their own organizations. So I really emphasize it. I think it's a very valuable approach. And as you'll see, it can be relatively easy to explain to a broad audience, certainly a lot easier than more sophisticated methods or even the multiple regression. So the essence of this, the motivation for it comes from the problems with a before and after study. A before and after study does not provide good causal evidence, is not internally valid if the dependent variable would have changed anyway without the independent variable change. So remember those examples about like the new executive director to the nonprofit who's really inspiring, brings in the new scheduling system, and productivity goes way up, but that new director was doing other things. Or think about how people sort of assume that presidents are responsible for the economy, but there's a lot of other stuff driving the economy, and the economy would have changed anyway without the president's policies. So that basic weakness is the motivation for a difference in difference. The idea is that we need something else, some other group, some other nonprofit, some other United States, ideally that would give us something to tell us the counterfactual. Well, as you can see from my example, that's not possible in every case, but it is possible in a lot of cases, as we will see. So some group had a before and after. There was a program change. The law changed in one state or in a group of states. We need another state or another group of states that are similar enough in the right ways, and we'll get into what that means shortly, to tell us, hey, what would have happened to the outcome? How would the outcome have changed if they hadn't had the new law, the new tax, the new regulation? Something to tell us that counterfactual. So a difference in difference study combines a before-after comparison with a treatment comparison groups. Both groups start with the same treatment, the same independent variable value, such as not having a particular program. And then that changes for one group, the treatment group, such as them getting a new program. The other group doesn't get the new program. Their independent variable doesn't change. And what we use is we use that other group, the comparison group, to show us the counterfactual. We assume that whatever outcome change happens for them is the outcome change that the treatment group would have had. So the idea is like a time machine, another reality. So the example we have in the book is from a parental notification of abortion law in Texas. A new law required teenage girls under 18 to have parental permission for abortion, whereas teenage girls 18 and over did not. So the first step is to calculate the change in the outcome after the law in birth rates for those above and below age 18, and then calculate the difference in the two changes over time. A side point, you may not think that teenage girls 18 and over are a very good counterfactual for teenage girls under 18 and wonder why they didn't just use another state. In fact, these and other researchers had done studies like that. for complicated measurement reasons. Basically, what happens is that, a girl who's under 18 by a few months will just wait. And the information needed to distinguish that was only available in Texas with a lot of security. So that's off topic. Just wanted to let you know because people often wonder about that. So back to diff and diff, how you do it. Well, the key to a diff and diff are these 2x2s. We have a before the law was passed. We have an after, and then we have a treatment group, and that's girls who conceived at 17. So that measurement issue was finding the conception date. So the treatment group are Texas teens who conceived at 17. The comparison group is Texas teens who conceived at age 18. And we see what the decline is in abortion rates. They did both abortion rates and birth rates. I'll show you them both. You can see that it fell by 3.4 abortions per 1,000 females in that age range, in this age 17. Now, if you did just a before and after, you'd think, oh, okay, this new parental notification law reduced abortions by 3.4 per thousand. The thing is, abortion rates have been falling and falling and falling for decades. And in fact, also teen birth rates have been falling and falling. So abortion rates in general, abortion rates for teens falling. So how much of, if we didn't have this comparison group, we'd say, well, how much of that fall is due to the new law and how much is just whatever was driving the decline for other reasons? We wouldn't know. So what we do is we use the teens who conceived at age 17 as the comparison group. Notice that they have a higher level. Look at that difference. You might say, oh, that is not a good comparison group. Well, it's not ideal. The very higher level from the teens who were a year older is not an ideal comparison group. It's very true. And the researchers looked at the prior trends. They looked at them in various functional forms. You can look at the paper if you're interested. And this was kind of the best they could do. But I spoke to one of the authors, and he is very open and clear about, yeah, it's not the perfect comparison group. We'll get to, in a couple of slides, why different levels in and of itself is not a problem for diff and diff, but still it's showing you, hey, the comparison group differs in some important ways. Nonetheless, what we do is we assume, and I emphasize assume, that this reduction in abortion rates is what you would have seen for the girls who conceived at 17 without the change, without adding the parental notification law. So how do we estimate the effect in the difference in difference? We take this decline in the treatment group, the minus 3.4 per thousand, and we see how different it is from this change in the comparison group, the decline of 1.5 per thousand. We get our difference and we say, hey, the treatment group, the 17-year-olds who were exposed to, affected by the parental notification law, their abortion rate declined by 1.9 per thousand, more than the abortion rate in the teens not affected by the parental notification. And this is our estimated effect. You can see this also for birth rates, right? What happened to birth rates? You might think that, hey, the parental notification scares teens, they're less likely to get pregnant. And so, or you might think that more likely, that because of the teen notification, teens who would have had an abortion didn't and actually gave birth. So what does the evidence show? So what we see from the top line, if we just did a before and after, there's this very slight decline in birth rate for teens who conceived at 17, 0.2 per 1,000 17-year-old female. But look in the comparison group, not affected by the law, birth rate fell by 2.9 per 1,000. Again, teenage birth rates have been falling for decades. So what do we estimate the effect of the law was? We see minus 0.2. Barely moved, but it fell by a lot more for the comparison group. So the estimated effect is that the parental notification law did raise teen birth rates, did raise the birth rates among the teens who conceived at age 17. In other words, teens who would have gotten an abortion and therefore not given birth, nonetheless gave birth due to the fact that they did not get an abortion due to the parental notification law. So that is how Diff and Diff works, but there are some serious assumptions here. The change in outcome that the treatment group would have happened is the change the comparison group did. And that the only relevant difference is the rate of change. So that a starting difference in the level, like we see here, that's okay. We just need that the rate of change is the same. And there are two things that you need to look for in a difference in difference study to see if that's reasonable. The first is prior parallel trends. Okay, so here in this case, here's the treatment group in the lower rate, as we saw, like the 17-year-olds. Here's the 18-year-olds, they have a higher rate. Here's the time with the new treatment. We're going to look, ideally we'll have lots of past data and we can see if the rate of change were the same, if the trends were parallel. So whenever you have a Diff and Diff study, one of the key things you want to look for internal validity, meaning for how much you really believe the causal estimate that you get, is you want prior trends, ideally as far back as possible, and you want to see that they are parallel, that the rate of change was the same before that. That's the first thing you're going to look for. I'll talk about the others. But before that, I want to sort of walk you through this chart and see another way you can get the evidence. So sometimes Diff and Diff evidence presented in a table like I showed you. Sometimes it's presented graphically where you see trends in time. Then you have the treatment. You have your comparison group. Nothing happens to them, so they go from that height up at B down to height up at D down to B. Here's the treatment group. They started at E at a different level, not ideal, but not necessarily a problem. And we observe that they go down to A, right? So B, D, E, and A are the only data points observed in the real world. We assume, and I emphasize it is an assumption, that the treatment group, if it hadn't had that change in treatment, like no new parental notification law, their rate would have fallen in parallel with the comparison group and they would have gone to place C. So the Diff and Diff estimate of the effect of treatment on outcome is that height AC. That height. So in this case, it's that, hey, it fell all the way to A. It was a negative thing. It fell down to A minus C. It would have been at C. So you will often see diff and diff results presented in graphic form like we had in the practice problem example in class. What's the other assumption that you want to try to look for evidence, maybe qualitative evidence about? And that's the idea that the only relevant treatment, the only relevant shock that's different between the treatment group and the comparison group is that law change, right? So, supposing, I don't know, something happened in Texas high schools that would have mostly affected 17-year-olds and not 18-year-olds who would mostly have graduated. If they made some change in high school rules and that could have affected birth rates or sexual behaviors or decisions to have children, decisions to have abortions, things like that, or maybe some rule about Texas State University admissions or something. I'm struggling because I don't think there's an obvious one in this case, but in some other cases it's obvious. Remember our new executive director of the nonprofit example, and the Asthma and Olympics example. What else is going on? Diff and diff is meant to deal with the what else is going on. That's the reason we had it, to get a comparison group who got all the other stuff. The weather, the politics, whatever changing social norms have been driving down teen birth rates and abortion rates. But those shocks, those changes have to be the same for the two groups. Again, we're assuming that the only shock that's different by the treatment and comparison group is the treatment itself. All the other stuff, politics, the economy, weather, social norms, all that other stuff, it's got to be the same for the two groups. We're assuming that. Maybe we should look for some qualitative evidence, other kinds of things, tracking other variables out there to look at that. Unlike the parallel prior trends, which we can both look at and there are actually formal statistical tests for, we don't have that one for this one, assuming that the only differing shock are the treatment ones. So there are big assumptions, but on the other hand, diff and diff is much stronger than your standard pre-post or even interrupted time series a lot of the time. And it's much stronger than a simple cross-sectional comparison. So it's a good one. And finally, speaking to the practitioners among you, you can make it a good design in reality. You can think, hey, let me roll out my program with a first rollout group and a later rollout group who are as comparable as possible with prior parallel outcomes. Then I can see how did the outcomes change in the early rollout group compared to how they change in the late rollout group. All right, so that's the basic idea of diff and diff. Diff and diff is often, however, done with more than two periods and often more than just two groups. You've got repeated measures, repeated observations of the outcome over time for the same individuals. Those individuals can be people, they can be schools, they can be states, they can be counties, they can be hospitals, they can be whatever's relevant. Then with repeated measures of both the data and the independent data, panel data, can be used to extend the diff and diff. More periods of time, more individuals. Basically, you're just getting a weighted average of lots and lots of different diff and diffs. So the panel data give you this within subject variation. Each person is kind of their own control, just like the simple diff and diff. In that formulation, you're just using the within subject variation. So the example we had in the book was the effect of marriage on men's wages. Cross-sectional studies showed that on average, married men earn more. We want to know, is that causal? Or does marriage cause men to earn more, or does earning more cause men to marry? Or does seriousness or some omitted variable drive both marriage and higher earnings? So the strategies, we observe men over time, see what happens to their wages when they marry and when they divorce. So here's like the basic idea. And the real point is we're just using the comparisons. So we're comparing man B in between years 2 and 3, change in treatment from single to married. Man D in year 1 to 2, single to married. And then married back to single. And man E in 4 to 5, single to married. Then every single other man in every single other period is a comparison group. Staying single, staying single, staying single. Staying married, staying married, staying married, staying married. They're just comparison groups. So this has a number of weaknesses. Only the changers are really contributing to that treatment group size. It lowers your effective sample size. Generalizability is unclear. Maybe the types who just stay single or stay married are different. Coding errors are a disaster. Is the time scale right to allow the independent variable to affect the dependent variable? And most importantly, could changes be endogenous? Do women choose to marry men who are going to have wage increases? So that was quick on panel diff and diff. If you take the more advanced quantitative methods course, you'll learn a lot more about that. And many of the diff and diff studies that you see in the policy literature are panel studies. A ton of them are done with, 10 years of state data where, we have, states changing their laws or rules or programs. The book has a few other examples of types of studies, and there are in fact lots of them. I'm only going to talk about one more in this lecture, regression discontinuity. That's become a very important one and a very strong one. Regression discontinuity studies have been shown to reproduce the estimates from randomized experiments, which, as you know, are the gold standard. So that's really impressive. So I'll start with an example, and then I'll tell you the general idea of regression discontinuity. So the idea is, in this case, so suppose students are accepted into some developmental reading program only if they have a reading score below a certain score. Above it, any amount above it, even just tiny above it, no developmental program. Any amount below it, even just a tiny amount below it, they're in the program. So the basic idea is, gee, maybe it's just random luck whether you're a tiny bit above or a tiny bit below the cutoff. So the students just below and above the cutoff should be the same. It's almost random. The noise of how they, felt that morning when they got up, too much coffee the night before, too little coffee that morning. They're going to be really similar. So the idea is to see the effect of the program. We just look at what happens to the people above the cutoff and below the cutoff. Okay, so here's the diagram that you should expect to see in regression discontinuity. Here is their GPA later on in their program. And here was the comprehension test score, the reading test score that determined whether they had to do the developmental program. So the people just below had to do the developmental reading program, the people just above didn't. So you might expect that if there were no such program, yeah, the better people do in this reading comprehension, the higher their GPA in general. So if there was no such program, we might just expect a line kind of going up there. But we did have the program. And remember, our idea is that the people just below and just above are the same. So you see that big jump in GPA, that kind of implies that the developmental program raises GPA. It kind of raises it by that amount. Because, you know, these students just above the cut point and just below the cut point, they're really the same, except for the fact that the ones just below had that developmental reading program, and so that height is our estimate for how much the developmental reading program raised GPA. Now, a problem with this method is we may not have very many people on either side of it, so not much precision, right? Not easy to get statistical significance. To expand that, and why it's called a regression discontinuity, they include in the study people with the much lower and much higher scores, and they kind of give you that slope. They're kind of giving you, you know, the idea of what the slope would have looked like without, you know, the developmental program, and that aids in the precision. A regression discontinuity study, you always want to see an image like this. You know, because often they're also adding all kinds of fitting and control variables and fancy things. And that's not necessarily wrong. There can be lots of other differences between these groups. Maybe how much their socioeconomic background and how much they have to work during college. There might be lots of other things going on that you want to include. Well, how much they have to work in college, say, before this or something. You don't want a mediator. So, you know, that's not necessarily wrong, but if the raw data don't look compelling, you should be skeptical. So you always want to see a picture like this. So could you do a regression discontinuity in your organization? And the answer is anytime you have any sharp cutoff that affects being in the program or not, or the value of the independent variable, yes, you can. It could be a deadline, like, or say admissions are first come, first served. You take all the people who apply before a certain date, you get full, and you don't take anyone afterwards. That's a sharp cutoff point. It's probably not random who applies really early and who applies really late. People close are going to be really similar. That sharp cutoff will enable you to do a regression discontinuity. That's not usually something you can control the same way you might be able to control the rollout of a new program for Diff and Diff, but it's something that occurs often in the real world and that you can use to estimate a good causal effect. So, big picture. Natural and quasi experiments are really tons of different methods. You want to think about how to get comparability and exogeneity. Can you find them through luck? Can you create them, even if imperfectly? Difference in differences is often realistic in workplace settings, and it's a big improvement over the kinds of causal evidence that you often get in an organization, which is very often just pre-post, or some cross-sectional comparisons that are really not very good comparisons. Okay, so that's it for natural and quasi experiments, which are really this whole big bundle of approaches. And again, I just want to encourage you to look for naturally occurring exogeneity and comparability, and also to try and create it when you can do so. this is something, again, I'm so happy when I hear about former students who are practitioners who are really able to change the rollout of something new, try something new in a way that gives them really good causal evidence. And I hope you'll look for opportunities to do that. Finally, I want to talk about what all this has to do with big data and analytics. And the answer is that there's so much data out there now and so many things that are being measured. And you can turn that data that's constantly being measured into convincing causal evidence by creating exogenating comparability or looking for it and finding it. But especially also not misinterpreting descriptive non-causal evidence as causal. So you can be part of the effective use of big data and analytics and not all the misleading being misled world. So thank you very much. And that's all I'm going to do for lectures for this book and this course.